I'm Carla Schroer of Cultural Heritage Imaging, and in this video I'm going to talk about why you should be shooting in your camera's RAW format, especially if you're doing photography for things like reflectance transformation imaging, photogrammetry, or other documentary approaches and trying to create archival data that other people can reuse. So image file formats, there's a bunch of different ones. The ones I'm going to be focusing on here are your camera's RAW format, and then formats we can produce from that, such as the digital negative format, TIFF format, and JPEGs. So RAW files, RAW is not really a format. It refers to the unprocessed data that the sensor in your camera detected when you took a photo. And so there are a variety of formats that are in that sort of basket of raw, unprocessed, minimally processed files. If you're using a Canon camera, it's likely called a CR2 or CR3, NEF for a Nikon camera, and so forth. So let's talk a little bit more about the RAW format and what the advantages of that are. We're getting that unprocessed or minimally processed data, which is carrying a lot more information than if we told the camera to take a JPEG. So a JPEG is an 8-bit file, and the sensors in modern digital SLRs and mirrorless cameras can detect 14 bits per pixel per color channel. I'm going to talk more about that in a little bit. But essentially, if you shoot JPEG in your camera, you're just throwing a bunch of information away right off the bat, and the computer chip inside your camera is processing that data in ways that you can't control, and likely applying things like sharpening and saturation and other things that you don't want to do. You can't properly color manage that data, white balance that data. You can't do any exposure compensation without data loss, and so forth. So shooting RAW gives you full control over the processing before producing whatever your finished files need to be, DNGs, JPEGs, TIFFs, etc. The disadvantage of the RAW format is it's not archival, so we have to convert it to something else. And it's not archival because it's proprietary. They change all the time. They're different for every sensor that is produced by the camera manufacturers. So we really want to take advantage of getting the most data that we can and then convert it to something that's archival. So our recommended archive format is the digital negative or DNG format. And what the DNG is first, it's an extension to the TIFF specification. So at its core, it takes the RAW file from your camera, and there are a variety of converters out there, including free ones from Adobe, and it converts that to a 16-bit TIFF. And that TIFF file does not have any modifications applied to it. Instead, it tries to make that TIFF as close to the unprocessed RAW as it can. And then any modifications you might want to make, such as color management, lens corrections, distortion correction, all that kind of stuff, none of that is actually applied to the image data. Instead, it is stored as metadata, and that metadata is in a format called XMP. So you have a record of everything that has been done to the file, and you can open a DNG and back out some changes and add in other changes to the image data. Now, the DNG can also optionally include the original RAW data. Now that does double your file size, but it gives you the safety net of being able to get back to the fully raw data that came out of your camera if that becomes necessary for some reason. I tend to think of the DNG as kind of a basket or a wrapper that has these three parts that can be in it. Two of them are always in it, and one is optionally in it, which is that raw data. Now, the disadvantages of the digital negative format is that not all applications properly manage the transformations to the image data. So when you go to open a DNG, some applications will just open the TIFF that's in the middle, which means you've just lost all of your carefully done color management, for example, or other modifications you may have done to the images. So you really need to understand whether or not you can use a DNG in another application, or whether you need to make some intermediate file that you're going to use there and just keep the DNG as your archive file. Also, not all applications will apply the transformations or the image modifications identically. That's just the nature of software. Different algorithms, they won't be bit for bit identical when you open these files. So let's talk for a minute about the TIFF format. As I said, the DNG format has a TIFF at its core. So what makes it different from a regular TIFF? The big difference is that once you create a TIFF, those image modifications we've been talking about, curves and white balance and so forth, they are actually modified in the image representation per pixel, and that information is baked into your image file. And so that could be a pro or a con depending on your situation and why you're making that TIFF. But the disadvantage is you may not have a record of the changes that you've made, and you may not be able to back them out or remove them. And sometimes that's an advantage. If you want that TIFF file to be the primary file after modifications are made, that is the primary file used for, let's say, publication or other uses in a museum, it's great to have a TIFF that has exactly how it should be processed built into it. Another big advantage of the TIFF format and why it's at the center of DNG is because it's widely used and it's supported in many applications. So let's just take a moment and talk about bit depth. We're talking about 8-bit, 14-bit, 16-bit. What does all this mean? Well, each pixel in your image is comprised of a red, a green, and a blue channel. Okay? In an 8-bit file, like a JPEG, that means there's 8 bits for red, 8 bits for green, 8 bits for blue. And a bit is just a 0 or a 1. Okay? So with that information, which is 24 bits of information per pixel, we can represent the range from dark to light, from black to white, with 256 steps. And I'm not talking about color, just black to white. In a modern DSLR or mirrorless camera, such as Canon, Nikon, Sony, those capture 14 bits per pixel. They store it in a 16-bit file format, because there isn't a 14-bit file format, but a couple of those bits are just not being used. And what that means is we have 42 bits of data for every pixel. And that allows us to represent the range from darkest or black to lightest value with 16,384 steps. Now there are higher end medium format cameras such as Phase 1 or Hasselblad that capture a true 16-bit image per color channel or 48 bits of total image data per pixel. And that allows us to represent the range from darkest to lightest value with 65,536 steps. So if we go back to the cameras we're primarily using in photogrammetry and RTI, we're looking at those 14 bits versus 8-bit. So here's a quick illustration of that where you can see the 8-bit at the top and everything is stepped and we can't smoothly represent a gradient like we can with a 16-bit file. So quick idea of how this fits into an overall workflow. We're going to take our pictures, we're going to use the storage card on the camera or run tethered to a computer. Those are in the RAW format. We're going to take those into a tool such as Adobe Camera Raw, and there are other tools available. That one comes with Photoshop. And there we can do our exposure modifications, set white balance, we can create presets, all kinds of stuff. We're going to export that as a DNG, and that DNG is what we're going to archive, or that set of DNGs if it's something like an RTI. We may need to create our working files for putting into software such as photogrammetry or RTI, and that's going to be a set of JPEGs. We typically don't archive those. And we may optionally produce a primary TIFF file, as I mentioned before, and that would be archived, again, depending on the use case for our image sets. Thanks for watching. Don't forget to check out the other videos in this series. See you on the forums.